Hello, welcome to the sixth video in this series. In this video we're going to save in a file all of the instruments that we're able to trade on our account with a little bit of information. I'm starting off exactly where we left off at the end of the last video. I have the test IPYNB open. I'm going to right click on that and go to duplicate and call it instrument.ipynb. And now just do a bit of cleanup. We can execute the first cell we need it. We can execute the second one because we need a session. Double tap D and delete this one here. The URL will come back to, and then the rest, params we can delete. The response, we're not going to be sending any parameters in here, so we're going to type none, and then that's all we need so far. So the URL is the main point. We're now not getting candles, we want the tradable instruments on our account. So going to the Oanda documentation, that's in the account endpoint. We've seen it in a previous video in Postman, and we have to put accounts, our account ID /instruments to get all of the tradable instruments. So let's do that. So instead of instruments, we'll type accounts. The placeholder will have defs.accountid and then /instruments. So shift on enter on that should store something in this URL. Let's have a look at what it is. Mine is here with the account ID, and we have instruments here as our endpoint. So going back to the Oanda documentation, we see that we should get a 200 response if everything runs okay. So let's check. So let's execute that and have a look at the response code, and I have a 200, which means everything should be all right. Now in the last video we hit shift and enter here to have a look at the response.json. We'll do the same thing in this one, and what we see is half of the data really. We've got something cut off here and there's a lot of information, and this often happens when you're looking at APIs. So let's go back to the documentation. In the examples section there's this get all instrument details for an account. So we can click on that, and here we can see the request, which is the same request as we've made. And now we can see the important part, the response body. So we get an object back, as we're familiar with, and it has a key in it, instruments, and that has a list. And in this list we have a series of objects, and those objects contain the various keys and values that describe each of the instruments that we can trade. So how do we get this list then? Well, let's store the response in a variable and we'll call it data. So at least our response, we're not now printing a load of stuff out to the console. We can have a look at what keys are in our data by typing data.keys, open and close brackets, and that will give us a list of the keys. And we know we have the instruments key because we've just seen that in the Oanda documentation. We also have a last transaction ID, which we can ignore. So we want the value, the information behind this key, so behind this door that we open with the instruments key, and that will give us our list. So we can type instruments is equal to data, open square brackets, and then instruments in speech marks. And that now gives us our list of instruments. However, if I try and put this into the console or print it in the output here, we still get a huge amount of information and we're cut off at the top and things don't look very good. They look a bit confusing. So let's try and have a look at one of these instruments. We know that the instruments are a list, and we can access each object or item in a list using an index of the position it is. So is it in the first position, the second position, the third, and so on. However, when you're coding, you always start at index 0. So if we want the first item on the instruments list, we can use square brackets with a 0 between, and that will give us the first item on the list. And we can see here that for the key name, we get the value euros silver, the type is a metal, display name, and so on. We can also look at how big this instruments list is as well. So let's delete the square brackets and 0, enclose this in curly braces, and before it put len. Len is a keyword in Python which will give us the length of a collection, or in this case this list. So this will tell us how many objects are in this list, and we can see that we have 124 tradable pairs. Now we would like to create ourselves a table and store this table for later use, and in this table we would like certain bits of information. So we need to know what keys we want to use to store this information. So much like we did here with the keys, with data.keys, we can do the same things on an instrument object. So let's take the first instrument again and type .keys and shift enter and have a look what keys we have there. And now we want to save the name, the type, the display name, the pip location, and the margin rate, because we'll need that much later on when we start trading. So what we want to do is we want to make a new list of some new objects that just contain this particular information that we want. So to do that, we're going to iterate through every single object in this list. Now if you're not familiar with this, I'll demonstrate it very quickly. Let's say we have a list, we'll call it LL, and we have the values. I'll just put some random values in here, it doesn't really matter. And I want to loop and iterate through each of the items in this list here. It's very simple. I just type for item in LL, and you can name item whatever you like, as long as it's not a keyword from Python, and then print the item, and we can see we get 2, 5, 32, 4, 60. So what we've done is we've looped or iterated through every item in this list, and each iteration, item gets the value of the corresponding entry in the list. So in the first iteration, item has the value of 2, the second iteration the value of 5, and this is then printed down here. We're going to do exactly the same thing with our instruments list. So we're going to loop through every item. So I'm going to say for item in instruments. Instead of LL, we're going to type instrument data and have the square brackets because it's an entry list. And then for each item, we're going to make a new object and set that equal to a dictionary. Remember, that's more or less identical to an object. It just has slightly more functionality and easier syntax. And now we want to enter the properties that we want. So we're going to say we're going to have name, and that's equal to our item, open square brackets, and the name. Then we want the type, and that's equal to our item, open square brackets, type. A display name, which is equal to item, open square brackets, display name. Pip location, which is equal to item, open square brackets, and the pip location. And margin rate, which is equal to item, open square brackets, and the margin rate. And don't forget the commas. Now we've created our object, what we need to do is add it to our instrument data list. So to do that, we type instrument data dot append, open brackets, and new ob. And that adds our instrument data to our list. So now Shift and Enter runs that code, and believe it or not, now we have all of these instruments inside our list. So let's just try and print some of these out very quickly. So we'll iterate through this list and type for item in instrument data, and then we'll print item. Shift and Enter, and you can see now that we get a much easier to read list, and we have inside our list of instrument data all of the tradable instruments with the name, type, display name, pip location, and margin rate. So I'm just going to change this slightly and just loop through the first 3 of these so it doesn't take up so much space. So if we open some square brackets and put a 0 and then a colon and a 3, this will actually show us the items at indexes 0, 1, and 2. So it goes from something to something, so from 0 to 3, but not including the 3. A shorthand for this would be just to take away the 0 when you're starting from 0. But it makes it a little bit easier to read. So the last thing I'd like to do then is actually put this into a table, or what's known as a data frame. So at the top here, you remember we installed pandas. I want to do import pandas as PD and hit Shift and Enter. Now, we imported requests here and we used the session functionality of the requests. We're going to do a similar thing with pandas. The as PD means instead of typing pandas, we're going to type PD. So requests here, when we used anything from requests, we typed requests dot. We could have typed requests as RE, for example, and then here we would have typed RE instead of requests. And this is what's known as using an alias. But in our case, we're going to use an alias PD for pandas pretty much because that's kind of standard when you see any data science stuff or data stuff with pandas. 99.9% of the time, the shorthand PD is used. So we'll use this as well. So if somebody else sees your code or you share it, they know that you're using something from the pandas library. So scrolling back down, pandas, tables in pandas are what's known as data frames. You can think of them a little bit as like Excel tables, except they're a lot faster, there's more functionality, and they're built a little bit differently. But for all intents and purposes, you can think of them as a table. And I want to put all of our objects into a pandas table. So the way we're going to do this, we're going to say instrument underscore df, which is a new variable, which df can be our data frame. You can name this whatever you like. For me, it's kind of sensible like that. And we'll say it's equal to PD, which is pandas, dot data frame, which is a table in pandas, dot from underscore dict, so get a table from a dictionary, and in open close brackets, our instrument data. Hit Shift and Enter, and now what we have is we have a data frame, which is a table of our instrument data. If I just put this in here and hit Shift and Enter, you can see that we have 124 rows and 5 columns of data, and we have all of our instruments that we can trade in a nice tabular format. So the very last thing I'd like to do then is to save this to a file. To do that's really simple with pandas. We're going to type instrument underscore df dot to pickle, open brackets, and then in speech marks the file name, which can be instruments.pkl. And when you Shift and Enter, you'll see that you'll have an instruments.pkl file created here. So what is a pickle? A pickle is a binary zipped format that is provided by pandas. It's a lot smaller than saving pure text or a CSV or something like this. So when we use other notebooks and our other code to get our instruments, we no longer need to go through this process of asking the Oender API. We can simply do something like this. I'll type new table is equal to pd.readPickle and instruments.pkl. And if we do shift and enter on our new table, you can see that we've loaded the new table. So in future code, we just need to run this line here to load up the instruments as we need them. Right then, that's it then for this video. In the next video, we'll get back to loading a lot more candle data. So thanks very much for watching. Any comments, questions, problems, or anything, put them please below the video. Otherwise, thanks for taking the time and see you in the next one.